with this CSV file extraction in mind, let's now take advantage of it and see if we can find a way to visualize the information. Now, you may not have PyLab installed on your computer, but it's a very useful module that comes with the nthought distribution. I'm not going to make it required because I know there's been some problems getting it installed. But when you look at its capabilities, I encourage you to really look into it, especially if you move to MATLAB, where you also will find yourself doing some analytics and visualizations. Now that I've got this information, as I mentioned, two different data sets, one being the real estate transactions, the other one being the criminal transactions, can I find a way to plot them to see what kind of information I might correlate between those? Well, we have to break it down into smaller steps. If I could just find a way to plot one point on a map, then I think I can convince you that I can plot all these blue and red points. So let's tackle that problem. And the sample code that I'm going to show here, I'm going to make sure you have available. So you should retrieve it when you can. Let's start. You've already seen the extract all records from the first video I posted. This is the new function that I want to introduce. This is useful when you are just trying to make sure that you have the right information. I just want to plot the very first real estate transaction and see if I can find out more information about that real estate transaction and plot it on the screen and see if I've more or less found the right location. To make this work, I provided for you some information. There's an image file that contains the location of Sacramento within the appropriate GPS coordinates that I've identified here. This was some trial and error on my part to figure it out, but once you've done it, then you can take advantage of it, I guess. You've already seen the sales file and the criminal statistics file. I'll make this image file available by a link you can get from the lecture notes for today. What my plot just one for accuracy function does is extract all the sales records and picks out just one of them that the user has suggested, whatever the num is. It's going to find the latitude and longitude of that particular coordinate and print it out. Well, it won't print that out, it'll print out the information about the street address. It will use that latitude and longitude and do a scatter plot on the background image. To really look at and understand how the background image is drawn, you just take advantage of this PyLab background function. You don't need to understand how it works. Just take it for truth right now that it will actually give you the background on PyLab, so when you plot points, they're actually going to be shown graphically over a GPS coordinate system. So with that in mind, I will have a function that will read up all the real estate information, pick out just the one I'm interested in, the num1, find its latitude and longitude, plot it on the graph, and print out the street address. So let's try it out. As you see, I just did, but let's do it again. Plot just one for accuracy. This is the second of the transactions. And you can see that it's at 51 Omaha Court in Sacramento. And over here, I have a graph in PyLab with the same information. Now, what's nice about PyLab is that it gives you the ability to move among the space. So you can zoom in, zoom out, shrink, and do all those things. And to do that, I need to have my capability called zoom to rectangle. So let me zoom on in here. And there's a dot, you see it right here. It's sort of off of 99, and it's on the street right there. Let's hold that thought for a moment and go to the street address and see what we can find in Google with regard to that location. So Google, 51 Omaha, Sacramento. It will, or it should eventually give us a street address that I can show over here. Nope, let me get rid of these quotes. That's causing problems. Now, you can see here's 99. Let me zoom on out a little bit, see if I've come close to where it is. This is a little too close. So there's 99 in Sacramento. Try to get to the same scale that we had in that image I had before. So there's Florin, kind of see that right there. So let me kind of zoom in right at this point here. The thing to look for is the Sacramento River on the side and see how close I get to that. So on mine, so you can see here, I've got 99. There's a street 50, and that's going across right here. That's this one up there. There's 50 on the north. This is my street address here. And the dot being right at this corner suggests that at least I'm getting close to the location. This is the J8 road that's coming down here with this big triangle. So it looks like I'm close. Certainly not enough to do NASA, but if you're going to do some footwork on your own, this at least gives you an idea that maybe we're onto something. So I have this nice ability to plot a particular GPS coordinate using this latitude and longitude coordinates, as you see here, and that's where it gets put on the background. So it's a little extra work if I take that exact same setup to plot all the coordinates. And to do that, I'll just sort of show you what it looks like. This plot's just one for accuracy, and when you get a chance, look at the following. Let me plot them all. So I'm going to say plot all transactions. I don't need a number anymore. And I'll just say plot all real estate transactions. I'm still going to load them all up one at a time, but now instead of doing an individual one at a time, I'm going to say, well, for every sale in real estate, and what I want to do is, of course, remember I can't, the very first entry is the column heading, so that actually contains no information. So instead of doing that, I'll do a index for IDX in len of the range of 1 to len of real estate. This will guarantee that I skip the headers and I only get the actual sales. So now I have it. And then each of these will extract the actual point. I'm not going to print any information now. And when I'm done, I want to scatter plot the longitude points and the latitude points. So long points and the lat points. To make this work, I have to start with my long points and my lat points. Each of these will be appended so I get a pair, just like you saw in my earlier example. Long points append and lat points append. Now with all that in mind, it will go through, construct these lists, and do the scatter plot. So now, I want to plot all transactions. I get this. Quite nice, as the ability to do some quick data introspection to see where the transactions are occurring. A bunch down here, a new development over here, but certainly nothing in the middle of nowhere. So this is a step towards understanding how to write simple programs built on other functions that you've written. And the one that plays such an important role, this extract all records, once you've written it once, you can say to yourself, fine, you give me any CSV file, this will load them all up and give you a list of list records. What you do with it is up to you. And in this case, I've been able to demonstrate plotting just one, or here plotting all of them once you know the right column header to extract the GPS for one and the other. This is the second video here to demonstrate how to work with CSV files, how to work with lists of lists, and I also wanted to show you some PyLab stuff here. I will make this inverted JPG file available for you. What do you do with it? Well, when you finally get it, you want to put it in the exact same directory that you've seen all the other files be placed. The CSV files for the crime and the real estate transactions, as well as the Python file that I'm working on. And the reason why it's inverted has to do with the way that PyLab draws images, and it's not worth explaining. Just take it for truth, because when you run it, you see that I indeed had my graph properly oriented. So this is the second video for preparation for homework 6, and I encourage you to review the code that I'll be posting shortly on the web link, as well as this video.